Now let us understand one-hot encoding practically. So this notebook will be available at the resource section. Make sure you download it in order to follow what I'm explaining right here in this video. Now this notebook explains how to use one-hot encoding technique, that is using the library called as scikit-learn. So whatever we have discussed in the previous video will be automated by scikit-learn. Our task is to just call this library and call the function and pass the input to it, then it will convert it into the encoding of categorical variables that we input to this function. Now we are going to use the data from the flights in and out of Newark in 2013. So the package that we will be using is a pandas, and in order to import the data, the flight data, in fact, I'm going to use this stat model. You can clearly see right here I'm using statmodels.api as sm. So from this model or from this library I'm going to import inbuilt data. I'm not going to import any other data, but I will use inbuilt data so that we can directly learn the concept of one-hot encoding. The important module here is this one, and this module I'll make it right here. So one-hot encoder. So this is the function that we will use to perform one-hot encoding, and this is for categorical variables. So this is a feature transformation method where we convert the categorical variables into some numerical variables. So just remember, in the case of feature transformation, you need to learn two concepts. First one is a feature transformation of numerical variables using min-max scalar, and we already just seen about this, and this was what we call as a normalization. And normalization is done in the case of numerical variables. They are not applicable for categorical, they are only applied in numerical variables. Similarly, we saw the concept called as standardization, and we use standard scalar for it. So this was the module that we use, and we use it from scikit-learn library. Now this was for numerical data. Now speaking of categorical data, we have one-hot encoder. So use this one-hot encoder as a library, and it is available in the scikit-learn as well. So here is the library that we have imported. Now we are using the data, so let me run it first of all. Now we are using the data of flights as always, and we have imported it from the stat models package. Now see here, sometimes it won't allow us to just read the data directly. So read timeout has been just thrown us. So what you can do is rerun this. So maybe there is some server error while importing this data, but if you double rerun it, maybe sometimes you need to try 3 times, but eventually it will run. So in our case, it is most likely that we will get the data within the second run. So I have again executed the same data. Now we can see in any minute that data will be imported. So see here, now data has been imported. So now let us toggle all the screen. Now since the data has been imported, let us execute this. Then you can see in our data I have many null values. So this is the function that will check the null values, and this is the process that we call as a feature engineering or data pre-processing. It is same step. We check the null values, and here we handle the null values by dropping it. You can also do something like take the data frame and fill the NA values with some values that you want. You can either fill the NAs with 0 values, or you can also fill or impute with mean values or median values or some custom values. But rather than filling the NAs values, I have just simply dropped it, because in our case we have very large data. So in fact, see here, we have around 33,677,6 entries. So this much of data we have. So it is large data. So that is the reason if you have multiple NS, you can simply drop it. But in the case where you have less number of data, then rather than dropping it, you can use the concept of imputation. But for now, I really don't care about this imputation because I have a large set of data. So rather than imputing the value, I will simply drop it. Now this will convert our data into the hours, minute. We have already discussed it. It is the same as above. Now this will have the hour, minute, and this is kind of pre-processing step, and these steps depend upon your data. Now the important thing is we have divided our target variables. So here y is my target variable, x is my independent variable. Now I will execute it. Then you can see I have the data right here, and in my data you can see something called as categorical variables. See here, this carrier. So carrier is my categorical variables. Origin, destination is my categorical variables. You can see these many are my categorical variable. To show you what it mean by categorical variable, I can go down and take the data frame, and in fact it is X train now, because we have divided our data frame right here into the training and testing data set. So I have now training data, which is the same data. Now from this training data, maybe what I can do is take the pandas library and call the unique function, and within this X train, that is this data, I will get the carrier portion, so carrier column. So I want to check what are the unique values that I have in this carrier column. Then if I execute this portion, then you can see we have these many of unique values. So these are the categories. These are the categories of carriers. If you remember something like in the case of carriers, we discussed in the case of categorical variables, we discussed something like gender. So gender is my categories, maybe male, maybe female, maybe other. So you can see there is a categories here. So if any person is our instance, then his gender will be one of these categories. So that is what the carrier also contains. For each of the observation, there is this much of categories, and for each of these observation, it will have among one of these categories, same as gender. Now we have many categories in the case of carrier. Similarly, we can also check what is the origin categories. So I'll say origin categories. So we have 3 categories for origin. So origin here means a source from where the plane has been taken off. So this is our original source, maybe something from where the plane has taken off, and DEST here is the destination. So you can see these 3 are the airports. They are the code of the original, that is source from where the plane will take off. And now we can also check for the destination. So I take the pandas library, PD is here a pandas library, and call a unique function to check how many categories are there. And now I want to check the categories for this destination. DEST is the column name. So from Xtrain, I have just taken out DEST. Now if I execute this, then you can see we have so many destinations. So this data is essentially a data of the airport where the plane will take off from these 3 airports. So this is the code, airport code, and our destination are these multiple airports. So now you can clearly see they are categorical variables. Now if you directly use this type of data in our machine learning model, then some machine learning model will not use these categorical variables because they are not able to do it. They only work with numerical data. But here you can see they are not numbers. They are in fact string. They are not numbers. Now our task is to convert these strings categorical variable into numbers, and that is what one hot encoder does. So here one hot encoder is the function, and it is available in scikit-learn. So firstly, with this line we are creating an object of one hot encoder. So in this line we are creating an object of one hot encoder, and using this encoder object, here we use this encoder same object, we call fit transform function, and this is the function that will transform our data. And what we have given here is the categorical variables. So basically one hot encoder is not applicable in a numerical data, but yxtrain, here you can clearly see yxtrain is this data, and this data essentially contains number also, and it also contains categories also. So both of these categorical variables and numerical variables are given to this function, but this function will ignore numerical variables. It will only consider these strings categorical variable and it will encode it. Now if I execute this line of a code, then you will see it will take some time because we have a large set of data. Now you can see we have this many observation right here, and we have the sparse matrix containing 8956. So that means we have created nearly 9000 natural new features to account for all the levels of categorical features. If you remember about the categorical features, I have already discussed you in the theoretical sections. For each of the categories, a new column will be made. So that is the reason we have so many categories. So that is the reason we have made so much of columns here. So we made around 9000 new columns for each of the features that will incorporate our categories. So to give you an idea, let us say that I am having some data which needs to be encoded, and I have a categories like red, and green. And you can see in our example, I only took the 3 categories. Or uniquely, if you consider unique values, then it will be either red or green. We discussed it earlier. So we take only the unique instance as a categories, and for that unique instance we create a column for each of them. So red for one and green for another. So that is the reason, see here, for the destination itself all of these columns will be made. For the target or the origin, you can see these many columns will be made. So you can see for the origins, which is right here. So for the origins, you can see these are the unique categories. So for just countering these categorical variables, we will be creating 3 columns. And for countering the destination attribute, we will be creating these many of columns. So that is the reason we have around 9000 new features. Now this is the way to transform your categorical variables into numerical variables using an encoding technique that uses binary numbers, a combination of 1 and zeros, to represent our categories. Now this is the code. Just check out the code. It is only 1 line code. You should understand what is the theory behind it, and that will be all. So this is the code that will transform our categorical variables into the binary variables, or into the set of a binary feature for each category in the column. If you do not understand how the encoding will be done, then please check out the previous video of theory where we discussed how each of these category will be taken and it will be encoded into the binary features containing 1 and 0 values.